we are starting the chapter 2 review. Your test tomorrow will be over sections 2.1 all the way to 3.3. So the majority will be over chapter 2, but we will have 3.1 through 3.3. I put a review on RenWeb of possible questions that there could be. If you do those questions in the review, then you're good to go. Okay, so if you by some miracle can do all of them, there are a lot. It's not mandatory, so you can just work on that at your own discretion. Okay, but if you do those problems, or at least do one of like each subsection of problem types, then you'll be fine for the test tomorrow because you'll have already at least practiced them. Okay, so we're going to start with section 2.1. That's the first one. Try to condense everything as much as possible into these 10 minutes. So we're starting with section 2.1, which is basically just being able to write algebraic expressions from statements and knowing what the terms in a statement are. Okay, so first of all, terms are going to be things that are divided, so things that are sectioned off from each other in an algebraic expression by a plus sign. Okay, so for example, number 7 says 12y plus y squared. This right here, which ones are terms? The terms are going to be these two right here. So how many terms do you have? You have these two terms because they are sectioned off by a plus sign, okay? The plus sign is going to basically tell you what the different terms are. That's why it helps when you are working with algebraic expressions to turn everything that's a subtraction sign into a plus negative value of whatever it is, okay? Remember that we said that we would try our best to envision things not as subtraction, but as the addition of a negative, okay? Also, like in number 1, it says to be able to write an algebraic expression from the statement, and it says the distance traveled in t hours if the average speed is 60 miles per hour. So you have to be able to turn a sentence into an algebraic expression. So distance traveled, if it's distance, you want to use a symbol that's going to be easy to recognize. So D for distance is going to equal the distance traveled in t hours if the average speed is 60 miles per hour. So you would put the speed, which is 60 times t. Since 60 stands for miles per hour, right? T, you multiply t on there, you will have basically t would be hours, right? So then these will cancel out and you'd end up with miles, and then miles will point back to the distance. Okay, so d equals 60t. That would be basically the expression for the distance traveled in t hours if the average speed is 60 miles per hour. So you have to be able to do that, okay? And there are a couple of different examples that you can do. You can go back to section 2.1 and work on other examples as well. Okay, identifying terms, you know how to do that. Rewriting products in exponential form. Number 13, for example, has, I think it's 15z. No, it's 5z. So we're working on number 13. Okay, it has 5z times 5z times 5z. How do you turn this into exponential form? Remember, the exponential form is just things multiplied to each other multiple times. Here you have the same term multiplied to itself 3 times. So the way that you would answer this is that you would put 5z to the 3rd power. Okay, so be able to do from extended form, right? So from factored form, 5z times 5z times 5z, into exponential form, and vice versa. I should be able to give you one of these and then tell you to expand it, and then you expand it into that form. Make sure that it is in the parentheses to tell me that you're multiplying 5z times 5z times 5z, because this here, if you answered this, it would be wrong, because that tells me that it's 5 times z times z times z, so only the z is being multiplied. Okay, so make sure that the parentheses tell you what it is that you're multiplying. Parentheses are your best friends, okay? Use them over and over again. All right, going on to evaluating algebraic expressions. This is going to be more of what the test will be about. So evaluating algebraic expressions, solving algebraic expressions. which we're going to get to, solving algebraic equations, which is in the next chapter. So for example, number 19 tells you x squared minus 2x plus 5. And it tells you to evaluate it if x equals 0, if x equals 2. So this will be something on the test. If x equals 0 and x equals 2, and it's telling you to evaluate, then you should be able to know that evaluate literally just means plugging these things in. Okay, so you would answer for letter A. You would have two different answers, right? Evaluate if it is a solution, then really your answer is going to be, evaluate the algebraic expression, you would just plug it in. In this case, you would have 0 squared minus 2 times 0 plus 5, and then you would evaluate it. 0 times 0 is just going to be 0 minus 0, that's just 0 plus 5, that's just going to be 5, okay? So evaluating for A and then evaluating for B, you're also just plugging that in which case it would be 2 squared minus 2 times 2 plus 5. 2 squared is going to be 4 minus 4 plus 5. That's going to also give you 5 in this case, okay? All right, so you have to be able to evaluate expressions. I'm moving quickly, stuttering, because I'm trying to move quickly so that we can fit it all in a 10-minute video. All right, identify properties of algebra. I'm just going to do one of these, but your properties of algebra are going to be commutative, associative, identity, inverse, and distributive. And they're going to be applicable to both addition and multiplication, not subtraction and division. So if I throw a subtraction and division problem on there and I tell you to identify the property, you should say none because they do not work. So for example, here you have xy, this is number 27. Here you have xy times 1 over xy, and we know that this property is going to be the inverse property because you have the opposite. When you multiply that together, you get 1. So basically, you just have to be able to identify the different properties, okay? So that's going to be the inverse property, of multiplication. All right, and then also be able to complete statements like in numbers 33 to 36, where you use a property that you know to complete the statement and then be able to say what property it is. Using distributive property, we're going to do number 41 quickly. And we're in section 2.2, sorry. Forgot to change this. This is already from 2.2. So using distributive property, like in question number 41. Question number 41 tells us x times 8x plus 5y. Go ahead and distribute. Remember distributive property, you apply whatever's outside into both of the values inside. So x times 8x will create 8x squared plus 5xy. All right, this is algebra 1 stuff, pretty easy. Can you combine these two? No, because they are not like terms, but there are two terms here. There's this term and there's this term because the addition sign tells us what is and what is not a term. Okay? Pretty simple. Simplifying algebraic expressions. That's just combining like terms like we do in number 57. So we're going to go ahead and erase this one. Yaneli, how much time am I at right now?
9 minutes and 1 second.
Ooh, okay. All right, 57, number 57, we have x squared plus 3xy minus xy plus 4. Combine like terms. You're combining what you can combine. Remember, for things to be able to be combined, they have to have the same exact variable. They cannot have one more, they cannot have one less. So x squared is the only x squared that there is. Remember that if something does not have a coefficient in front of it, it means that it is 1. So you have 1x squared plus 3xy minus xy. This can be combined because the xy is the same variable. Okay, if you factor it out, it would be 3 times x times y, or 1 times x times y. Okay, combine these two, you get 2xy
plus 4 at the end. This is a constant. Nothing else can be combined, so this is your final answer. Okay?
You have to be able to do stuff like that. That's easy stuff that you can do. Go through those problems. Simplifying expressions as well. This now deals more into the multiplication. So if we do number 67, hopefully I can fit all of this into one video. We'll see. If not, I'll split it up and then upload it. So 67 is negative 6x times 2x squared. If you work this out, you're going to multiply, okay? Now when you multiply this, make sure that you're multiplying coefficients to coefficients and variables to variables. So first step would be to multiply coefficient to coefficient. Negative 6 times 2 is going to give you negative 12, and then you take care of the variables. Alright, so in this case, x times x squared. X times x squared, if you were to factor out, it would be x times x, which is the same thing as x cubed. So then this would be the simplified expression. Okay, you're taking something that's big, that's a lot of terms, into just one. And I don't want to say terms because remember there's no addition in between them, but basically two different values multiplied together. You have to be able to use PEMDAS, okay? Not going to go into that here, but that's the basic rundown of that. So that's sections 2.1 to 2.2. We're going to cut this video off now and then do the rest.